Picture this. You click on a game dev tutorial, you get your project up, you're excited, and then suddenly your screen looks like this.
Oh my god, bro.
And you're lost. Does this sound familiar? The truth is, every script you see shares the same fundamental concepts. As a full-time data engineer, I'll show you what you need to be able to analyze and break down any script that you come across. Using this knowledge, we'll be breaking down our own simple player script at the end of this video. These concepts aren't specific to a single programming language. If you want to see that, then let me know in the comments. Now, let's get going. The first concept we're going to go over are variables. Variables are how we store pieces of data. If we're assuming that the variable isn't going to change, then we will call it a constant. We usually assign these using the equal operator, and here are some examples on screen. Now, those words that you see before them like string, int, float, those are data types, which we will cover next. There's 5 main data types that you'll be working with in game dev: ints, floats, strings, booleans, arrays, and dictionaries. Now, let's go over each one separately. An integer is a whole number, such as 5, 50, 100, 1 million. Floats are a decimal point number, 3.14, 9.99, 4.59. Strings are any combination of characters, including no characters, in a set of single or double quotation marks. A bool or a boolean can be one of 2 values, true or false, sometimes 1 for true and 0 for false. An array is a list of values that are of the same data type, such as a list of float values, a list of strings, etc. They're represented with square brackets, and values are separated with a comma. You can get an item in an array through its index. Remember, the index starts at 0 and increases by 1 for each item in the array. The first word, cat, is at index 0, and the last item, dog, is at index 3. You can assign a new value in an array by assigning a new value to the specific index in that array. For example, if we wanted to change the first item in the animals array from cat to a giraffe, we would do animals at index 0 equals giraffe. The last data type we'll be going over are dictionaries. Dictionaries are a list of key value pairings stored inside curly brackets, and items in them are separated by a comma. In this first example, we have a dictionary called Toy Box. In it, we have 3 key value pairings: cars, dolls, and Legos. Each of these 3 keys points to a corresponding value: cars to 5, dolls to 2, and Legos to 20. For example, we can pull out the value for cars, which is 5, by referring to the cars key in the Toy Box dictionary. Adding a new key value pairing or assigning a new value to a key is done the same way. We first refer to the key that we want to add or reassign and assign a new value. Alright, on to operators. Here are the basic operators you can use. The output can be different depending on the data type that it's being operated on. There are the plus, minus, multiplication, division, and modulo, sometimes called remainder. You can use operators to assign new values to variables. For example, var x equals 1. Then we can do x equals x plus 1. So now x is 2. This is something we do very commonly in game dev, so there's a shorthand notation for this. X plus equals 1. It's the same thing as x equals x plus 1. You can do this with the other operators as well. We also have something called comparison operators. We have equals, less than, greater than, less than or equal to, and greater than or equal to. These are typically used to compare 2 different data types, and usually the last 4 on this list are used to compare either ints or floats. They return a Boolean value when used. Next up are conditionals. What if we only want to run a line of code if a certain condition is met, such as playing a jump animation when the space key is pressed? Or, what if we want to play it only if the spacebar is pressed and the player is on the floor? Well, this is where conditionals come into play. We define conditionals as a block of code that runs if a condition is true, and typically call it an if-else statement. Here we see an example of a conditional. If the space key is pressed and the player is on the ground, then we execute the code within the curly brackets. Else, we do something else. If we want to chain conditionals, we can add as many conditions as we want below the if, using the elif keyword. So we can say if condition 1, execute code, else if condition 2, we execute the code, etc., until our final else condition. Conditionals can be made up of multiple conditions. We combine these conditions using conditional operators. The 3 most common ones are and, or, and not. We'll only cover the AND and OR conditionals briefly in this video, but if you want to learn more about how they work, then I'll leave some links in the description below. If we combine conditions using the AND conditional operator, sometimes symbolized with a single or double ampersand, then the condition will only return true if both the first and second condition are true. For example, the block of code within this if condition will only run if the input is a spacebar and the player is on the floor. If only one of these conditions are met, then this if condition will not be true. However, for the OR operator, we only need one of the conditions to be true in order for the block to run. On to loops. There are two types of loops that we typically use: the for loop and the while loop. The for loop is typically used to loop over an array or dictionary. Let's say you want to loop over an array of integers. We first write for and then a variable name to assign each value in this list as we loop through it. We'll call this variable x. So what we could write is for x in this array of integers, we will print x. This will iteratively print each item in the array. The while loop is typically used when we have some starting assignments for variables and we want to do something to these variables while a condition is true. And once this condition is false, we exit the while loop. For instance, in this example, we have two variables, a fuel variable and a speed variable. The while loop checks if the fuel variable is greater than 0. And while this is true, we increase the speed and decrease the fuel. Once the fuel goes less than 0 or equal to 0, this while loop exits and the speed no longer increases. Here's another simple example of a for loop going over a dictionary of key and value pairs, printing the value at each key. Think of functions like a recipe for your favorite meal that you want to be able to recreate the same way every time you make it. Functions are these recipes in code form, reusable pieces of code that you write once and can call multiple times elsewhere in your scripts. You give them a name and add on a set of parentheses. These are where you can add optional inputs called function parameters. Think of these like the ingredients in a recipe, denoted between the parentheses and separated by a comma. If you want your function to have an output, then you can use the return keyword to return a piece of data that can be stored in a variable for later use, like storing away a batch of cookies you made to eat later. Then anytime you want to call the function elsewhere in the code, you can call it by its name, add the parentheses with any inputs it might have, and potentially store a return value in a variable. A class is basically a template for creating a new data type. It's also referred to as an object. Like functions, instead of having to rewrite the code for creating a new object every time we want to create it, we can instead create a class that we can instantiate every time we want a new object of that class. For instance, we may have a player class in an RPG. We lay out the template for what a player object is, such as its attributes in the form of variables, for example health or player name, and we can define actions this object can take through defining class functions, such as an attack function or a move function. Then all we need to do when we want to create a new player object is instantiate it like so. The instantiated object now has access to those attributes like health and to the class functions like move and attack. A class can also extend another class. For instance, imagine we had a car class with the attributes of mileage, color, and functions brake and drive. We can then create a new class called Mercedes that extends or inherits the car class. This means that the Mercedes class has all of the attributes and functions of the car class, plus its own specific attributes and functions, such as the attribute car make and the function zoom zoom. We define all this as object-oriented programming, and is one of the most important concepts in game dev, so I would definitely take the time out to research this concept further. If you have any specific questions on any of the sections, leave a comment and I'll be sure to get back to you. Finally, let's put what we've learned together and quickly go over a real example of a simple player movement script in Godot. The first thing you can see at the top is class name player extends character body 2D. From what we now know about classes, the player class has access to the variable attributes and functions of the character body 2D class. The next thing you see are 3 variables, 2 of them being constants, meaning they can't be updated. These variables will be used later on to update how the player moves on screen. The next thing you'll see is something very common when using a game engine, and that's the process function. What this is basically doing is running every frame per second in your game. This is called the game loop. So at a high level, if your game runs at 60 frames per second, then this function runs 60 times per second. It takes one function parameter delta, which is a float value. What you'll see next are 3 conditional statements. These conditional statements call on some class functions from character body 2D that return either true or false. Remember, these are booleans. Knowing what conditionals are, we can see that if the condition returns true, we can update one of the class attributes that player inherits from character body 2D, the velocity attribute. The velocity attribute is of class vector2, which on its own has its own 2 attributes, x and y. These x and y values determine the speed in which the player is moving in either the x or y directions. We then see at the end that we call a final class function move and slide. Already, we can see that without even truly knowing what each function does, we can see what kind of structure we are building for the player class. Using this knowledge, we can then go look up some of these class functions and attributes in the documentation to determine what they do. For instance, that's how I found out what the velocity attribute is and what it does. Remember, that's the real power of learning the fundamentals. And that's everything. I hope this was a helpful jumping off point for you in your game dev journey. If it was, then I would greatly appreciate it if you liked and subscribed for future content. I've linked some further resources down in the description below, and if you want to see the 3 tools I'm using to start my game dev journey, then check out this video here. See you next time, and thanks for watching.